Yo, what's up, everybody? Welcome back. Today we're working on my image editor, and today's task is trying to leverage 3D pipelines to generate 2D data. So, what am I talking about? Let's start by telling you what our image editor is. Here is our image editor. We've been kind of using this test case of Slurpee banister, Cersei Lannister holding a Slurpee sitting on a banister, so that's why these are the three images you're seeing when we open this thing up. But the editor has some features right now, right? So we can maybe cut something out, right? We can go let's cut out Miss Lannister here. And let's see, that generates some mask, that generates a masked object. Maybe we want to increase the contrast of this object, so we can take a user-defined shader, any user-defined shader, and we can say, okay, let's apply this shader to something in our list of objects, so we can apply it to the mask, or we can apply it to the masked object. We can say hey, let's bump up the contrast in this thing. And what's interesting here is that this is a completely user-defined GLSL shader, so we pass this thing in on the command line, the app goes, oh, let me see what uniforms are in there, expose those in the UI. We can then create a composition and say, within our composition, let's add in that contrast enhanced Cersei Lannister, as well as our Slurpee, and in here we can rotate stuff and scale stuff, right? We can kind of be okay, let's put this over here, this like this. Z sorting is kind of shit right now. We can only Z sort by changing the order in which we added stuff. But we're getting somewhere, right? And the past couple days, we have been working on creating drawing. So if we want to take this thing and we want to draw stuff on top of it, how do we do that? Well, we have basically said for every time we move our mouse on here, we are going to generate a distance field that represents the how to say this? A distance field that represents every stroke that we've taken. So let's kind of try to visualize that a little bit better. If I go into renderer, I can change our brush shader such that it will just show us the distance. Let's start there. So we go distance 1.0. I think if we restart this thing, we should be able to show you what we're actually doing here. So we'll create a drawing. Yeah, okay. So this is what we're generating right now, right? For each stroke, we generate this thing where we basically say, as you get farther from the center of the thing I drew, please get dimmer, is essentially what we're saying, right? And what's interesting about this is we can now apply any shader to this thing, and we can define our brushes as user-defined shaders the same way that we are defining contrast enhancement as a user-defined shader, right? This is not something that's part of the program. In the same way, any brush that we're going to have is not going to be part of the program. It's going to be something that we can define, and that's should be very powerful, right? Because you can imagine that instead of just doing a color for this thing, you could say, let me implement a spray paint can by basically sampling from a texture that looks like this, right? And also use my position in the brush in some way. You can do something that has kind of soft fall off, so you can have something that's gets stronger and softer like this, or you can something that has hard fall off like this. You could do stamps, right? So you could, in GIMP, you can do something where you go hold on, let's take a picture of something. In GIMP, you can go in here and you can use the stamp tool, where you click over here and you draw that by sampling that thing over here. You could do that same thing by just burning a shader that samples from another part of the image. You could do a smudge like you have in GIMP by doing something similar, where you follow the line and you apply a shader that samples from further back in the line, right? There's all sorts of things you can do that basically come for free. So that's what we're working on. But today I want to look at something a little interesting, which is the way that we're generating this mask is pretty stupid. We basically take all of our lines and we say, I would like to, if this is our line, we basically say, okay, draw this line to a texture. Now, draw that texture to another texture, but kind of outline what's already there. And then do that again. And then we'll outline that with this. And every iteration, we add 1 to the number. Which is it's kind of silly, but it means that if you have 1,000 by 1,000 pixel image, you have to run this shader 1,000 times, which is it's not really a problem if we're gonna be honest, but it's not great. More importantly though, our shader is wrong, right? So if we look at what we draw here, it's kind of jagged. you can see like the outside. Can we like make a new drawing? Maybe it's gonna be easier to show on a new one. Great drawing. Okay. Right, you can kind of see it's like kind of like sharp here, right? And it's because what we're doing is we're only sampling things above or below us. We can actually show you the sampling shader here. We look right, left, up, and down. And then we just like take the minimum of those things. We could fix this and add like look to my corners as well and then like pick the distance. But somebody in my YouTube comments sent me or told me to Google this paper. This paper called Fast Computation of Generalized Voronoi Diagrams Using Graphics Software. I open this thing and I'm like, oh, math, words, gross. I can't read. But the interesting part here is this. This is the most interesting part of this whole thing. Is this little picture. And what this picture is telling us is that you can essentially trick the 3D OpenGL pipeline into generating the distance mask for you, right? And the way you do this is you kind of represent every single point in your line as a cone, and every edge in your line as a little like tint, right? And what this will do is like, here, let's see, delete this shit. Say you have like a line like this, right? What you can do is you can like say, okay, let's add a plane kind of like here and here, and then another one kind of like here and here, and then another one like, I don't know, like this and like this, right? And then all of these guys, we're gonna kind of like rotate them down a little bit. Okay, so we're gonna be like, how do we do this? I guess we'll have to be a little bit clever here, but RY, 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 YY, no, RXX, yeah. The wait will be worth it, trust me. We're gonna see something interesting. And then let's kind of like position these guys again, just kind of hand wavy. You know, it doesn't have to be perfect. So if you draw these tents, what you'll notice is like these tents start to like intersect each other, right? And what's kind of interesting here is that the one that you can see, the one that's on top, is if you took the depth position at any point on any of these planes, they are kind of like the distance to the line, right? As long as you like slope these things such that like the depth increases at the same rate as like your distance in X and Y, you then are basically getting the whole distance field for free. And all you have to do is render this 3D geometry, which graphics cards are very good at doing. And you might say, hey, there's like a big hole here. And it's like, yes. But if we filled this in with cones, how do you do this? Cone. If just in every place that you like have a corner in your thing, you like stick a cone there. Right now, these like corners are kind of filled out. Now, obviously this needs to be like, you know, stretched out a little bit, whatever, right? But hopefully you kind of get the idea here, right? You can represent your line as a series of like tents and cones and get the OpenGL pipeline to create your distance map for you. So that's what I want to explore today. And then if we like manage to make this happen and work pretty good, then we can work on like adding different brushes and like making UI for those brushes and stuff. But then I think this is going to be the interesting part for today. So I think my plan is to start by trying to generate the cones and the little tents here. Try to figure out how to represent those things. Maybe export the cones and tents into Blender so that we can kind of look at them in 3D. Then try to figure out how to like render them with OpenGL. That's kind of the plan. But let's start by just like generating some 3D geometry. Fuck it, you know? 0915. All right. Set no number, set line break. We want this stuff to look a little prettier. And crazy hard to get. Yeah, sorry, it's not. I think I did a poor job explaining. But hopefully as we go on, it will become a little clearer. Okay, so let's go into our object storage. And somewhere in here, we have this like drawing object. Okay, and one of the we have like a function in here that says add a sample to this stroke. And as part of what we do here is we will go into like this distance field renderer and we generate a distance field. So this is probably the code that we want to look at. This thing takes in a vertex array, which isn't really what I want. So maybe right here for now, let's do some like generate 3D geometry. So again, reminder, since I don't think I explained it well, what we are looking at this point is like a series of strokes, right? So in our drawing, we'll have like, I drew this line and then I drew this line. So our data is 1, 2, 3, 4, 5 points on this, and 1, 2, 3, 4 points on this. A 2D array, 9 points, 5 in one, 4 in the other. So we want to say, for each point in geometry, generate a cone. For each line in geometry, generate a tint. So let's just start with cones. What is a cone, really? Like if we had to think about it, I guess we are trying to generate a cone that has like a slope of 1. Oops, what the fuck did I just do? Right? We're trying to generate something that has like a slope of 1, so that as it gets 1 unit this way, 1 unit this way, we move 1 unit this way. Is that true? Yes. Okay, so then what does that mean? We have like a singular point at the top, and I guess at the bottom, we have to draw like some form of circle, right? And then we're gonna probably have to triangulate this mesh such that like we have like kind of like triangles that approximate it like this, right? This is a cone. So we need to make our cone fat enough so that at any point that is drawn in our image, it will cover the entire image, right? We want to make sure that we have that we don't have like some area of effect. We want it to be fucking massive, right? So if we have like an image like this and we draw a point in the corner here, we basically want to draw a cone that extends like all the way out like this, right? Hand wavy, right? Something like this. Okay. And I guess we have the radius of the bottom of this thing is this is kind of like the radius if you were to project from the top down. And we know that the depth has to be at least this distance. Right, okay, so I think that all this is we have to make sure that since the depth and radius, these are equal, so we just need to pick a depth and radius that will be fill a image that goes from -1, -1 to 1, 1, right? So I guess 2 is reasonable. Now what's kind of interesting here is the coordinate space of this thing is kind of twisted, right? Like this is 1.0 and this is also 1.0. So that's going to be a problem for us, but it's going to be a problem that I'm not going to think about right now. I think for now we just have to pick which dimension we want to consider true, and then we'll just stretch the other dimension to fit that. So we'll consider width to be our square pixel. So let's start there. We'll say we will choose width to be our maximum. So what we'll say 1.0 is equal to, I guess maybe we'll make sure that 1.0 is equal to the skinnier one, skinny axis. I think that makes sense because we want to make sure that the whole picture is always filled, but I'm not 100% sure about that. I'm not 100% sure. Okay. So let's go back to thinking about like radius of a cone. So if I want to draw this triangle, so where kind of each of these distances is, I guess, this is R, which means that this is 1, 1, root 2. So this is root 2R is going to be the length of this line. Does that matter? Maybe it doesn't. Our coordinate system will just say we want to draw a circle, I guess at the bottom, and we know that we have R here. And I guess we'll kind of want to sample the circle at some interval, right? And then we can just draw this thing as a triangle fan around this thing, right? So we'll draw one thing in the center and we'll say draw this part of the triangle, then this, 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 and then we'll just move this like center point like up into the sky. That seems pretty reasonable. Can you please take the time to upload the code for experiment happy hour stream where you implement rotation stuff to gist or something? Well, all the code is in the GitHub, so you will be able to find it under GitHub Spheroforius It's probably in here as we have rotation implementation here, and then I think that there was panning implementation, aspect ratio zoom pan here. So you'll be able to find it, Neil. You'll be able to find it. Okay. Sure. So I guess we just have to sample a circle. That's kind of the problem that we have to solve first. Sample a circle. So how do we do that? Well, we start pointing forwards on X, and then we pick some angle, some ratio of a circle that we want to sample at, right? So if we want 4 samples, we'll kind of sample here, 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 and here, right? Let's start there. Function sample circle. Okay, so we're gonna have some radius. And maybe we want to do this as an iterator so we don't have to allocate. We'll call this like circle sampler. Okay. And can we go like IDX is usize, okay. And then the num samples is going to be usize as well. And we're going to have some sort of like next function that looks at our self as a circle sampler. And he's going to return some sort of like vec2, right? If our index is greater than or equal to the number of samples, we're like donezo, right? Otherwise, let's think about this. So at index 0, we return our vector 2 of 1, 0. Boom. Initial point. Okay. And I guess we have to apply some amount of rotation, right? So we're going to say like initial point, and I guess we're going to rotate this by some angle, which we kind of get for free if we look at like transform rotation by some amount, right? So I guess the amount is going to be num samples over 2 over math stood math pi, right? 1 rotation is 2 pi. But if we want to do like 10 samples, so if we have like 4 samples, 0, 1, 2, 3, 4th sample goes back to 0. Yeah, so I think that makes sense. So 4 samples is equal to 2 pi. So we want like num samples times question mark is equal to 2 pi, right? Which means that we want to do num samples. This is our thing. So we have something 2 pi over num samples times num sample times index. Yes. So when index is 4, this will be 2 pi. Yes. Yep. That seems right to me. So we probably do multiply first. Then we do divide after. And then we probably need to do some sort of like float conversion. So self index as a float. And then num samples f also. Okay, and then we can use this just be like idx f over num samples f. Okay, and then this is our angle. Okay. So we say that our transform is a rotation by that angle, and then we take our initial point and we apply a 101 because we need to use our homogeneous coordinate so that transforms work correctly. And then we should be able to be like, what? I guess over here we have to like increase our index. Okay. And then I think we need like linear algebra apply homogeneous to get back to vec2. And then we just return the point. That seems reasonable. That seems reasonable for sure. So can we put this somewhere? I kind of want to put this somewhere else for now. Oopsies, what the fuck's this? Geometry, so that we can kind of like play with this kind of outside the context of the application. I think that'll be easier. Transform, this is lin dot transform, and vec2 is lin vec2. Okay. Then we need const stud, so you have to import stud. And vec3 is lin dot vec3. Okay. So can we do like pub function main, and let's create a circle sampler. Okay, and I guess the index will kind of be hard coded to start at 0, but we do need to set the number of samples. I like Ogre. Somebody remembers my Dota playing. Oh, this is my real life friend. That makes more sense. I do like Ogre though. Just for reference, I've been playing Dota with my friends, and my profile is just all of my games. I just lock this idiot ogre mad guy who has 0 intelligence, and I just spam in the chat I like ogre the whole game. It's a real problem, but it does crack me up. It will never not be funny to me. I've been doing this for like years. And it never gets old. Choose from Amsterdam, love the stream. Hello. You're not allowed to say that you like the stream because you know me. That's cheating. I have an unfair advantage with you. But also, thank you. Okay, so if we're trying to sample circle 4 times, we can just do while sampler. Next, we have some sort of sample. And can we then say, what is the sample? I'm slightly biased. Yeah, slightly. Let's just do any and write the sample. Okay. Okay, zig, run, source, geometry. So this should give us something that looks straight to the right, something that looks straight up, something that looks straight to the left, and then something that looks straight down. Now, there's something a little odd here where we have these like non-zero values here. However, they are quite small. 1e negative 8, 4e negative 8. Those are like very, very small numbers, so we can kind of assume that those are insignificant, which means that our circle sampler is probably giving us the right thing. Love the stream, I'm a stranger. Let's go! So if this is giving us the right thing, now we can try to make like a cone. Cone generator. Okay. So we're trying to make a cone. What does that look like? It means that we want something that starts with 1 point in the center. Okay. We want something that has, I guess here we also want to define the radius. I think defining the radius of our circle here will be a little nicer. Right, so if we say that the radius is now like 4, we should be able to multiply this by like splat self radius. Oh, he's mad. As vec2 splat. Vec2 needs to be from the linear algebra library. So now we should be able to be like, give me this thing with a radius of 4. And that should give us 4, 4, 4, 4. Hell yeah, looking good. And now, okay, so our cone generator, we are going to basically try to give it a radius as well. But also a height. Yeah, that seems pretty reasonable. Okay. And I guess this will we'll put like the circle part at 0 coordinate, and then the top at like how at whatever height is. So I guess if we're expecting to use this thing with a triangle fan in OpenGL, then we should be like, uh, we'll generate the center point first. Okay. So each of these things is going to spit out some sort of like 3D point. That seems reasonable to me. Okay. And this thing is going to hold a circle sampler. So this is also going to have to take in num samples. Num points. Num circle samples. Okay, so this guy's going to have like some sort of circle sampler. But he's also going to have the height stored as his own thing. And then he's also going to keep track of if we are on the first iteration. Okay. So then here we can say like if is first. We say self is first is equal to false, right? And then we return what is essentially 0, 0, self height. That seems right. That'll give us the center of cone. Otherwise, we just return self base sampler next. Chillin', dude. That's pretty sick. That feels clean. So now we just say that the height is equal to the height. The base sampler is equal to whatever the fuck we put in here. Radius equals radius. And num samples equal num circle samples. And then is first is automatically set. And then we're chilling. So we're like, give me like a fucking cone generator, please. And this is going to be at radius, 4.0, height 4.0, num circle samples like 10. No, 4. 4 is easy to reason about. We need to init this thing. And let's see what we get. Fuck! This is true. So this is going to be the the base location is this thing. And then we have to convert this into a 3D point, which is like base location 0, base location 1 at 0, 0. That feels correct to me. Okay, so he's pissed off because here we have to say or else return null. Okay. And so we start with this thing at 0, 0, 4. Then we get 4, 0, 0. So this is going to be like center top, bottom right, bottom top, bottom left, bottom bottom. Nice, dude. That's working. Okay, so now what I would like to do is I would like to visualize this thing in 3D, and I would like to bisect the visualization of what we're generating. I would like to bisect like the generation of the cone data and like the OpenGL stuff. I think that will make my life easier. And so what I was thinking we could probably just like export this thing and like look at it in Blender. So I think we can just be like, yo, let's fucking make ourselves some OBJs and figure it out from there. So I think we literally just write a file that has our vertices in it. I don't know what this 1.0 dot is at the top here. Maybe we'll actually go the other way. Let's generate a cone from Blender. How do I delete everything? Let's just fucking make ourselves a cone. And can we like export this as an OBJ and then look at it? So I think we can just start like slamming vertices. We might want to say that we start as an object cone. That seems maybe reasonable because we could store multiple objects, but I think if we just don't do that, it'll be fine. So let's just fucking run it. So let's say, let's create a file that is cone object. Okay. You have a line there. That's okay. That's just like kind of like annotations. It's fine. We're basically gonna be like, let's write some shit into this thing. And what are we gonna write? We're gonna be like, I guess let's get our writer, and we'll go like, for each thing in this cone, we're going to write print vertex number number number. Right? That's kind of like the format we saw in this, right? Vertex number number number. Boom boom. Where the fuck we were just now? I'm lost. Okay. And then a new line. So here we're just gonna be like sample 0, sample 1, sample 2. Simple. Simple, simple, simple. Then after that, we have to kind of construct faces for this thing. But I think that honestly, if we just write this, I bet you this is importable into Blender. So can we like crank the number of samples here to like, you know, let's get crazy. 15 samples. Let's get wet and wild. Every time I've ever said wet and wild, I immediately regret it. It's just like in my head for some reason. Let's just get wild. We won't get wet. We'll only get wild. And I guess we'll prefer like an F close over here. And let's just see if we can like import this object. Import obj. Obj. So this should be like something that has points, right? We can actually see our cone here. It's got the wrong axis is up, which is kind of fun. But otherwise, it looks pretty good. Can we change that to say like forward axis Y, up axis Z? Does that fix it? Yeah, there we go. Cool. So now let's try to draw our faces. Our faces are just going to be, I guess, for 0 to 15, right? Because that's how many samples we have. We're going to write out a face that is the index of that goes from the top, the first index. And what is the face structure here? It's slashes. Slashes. No, here. Like this. 1, 2, 3. Okay, so we go from 0 to I to we'll call this like const left is going to be I, and then the right is going to be I plus 1, but we have to kind of wrap around somewhere because at some point we're going to hit the last element, and that's going to be like I guess it's like I percent 15 plus 1. I percent 15 maybe even. I plus 1 and I plus percent plus 15. Yeah. Because the first bottom index is on the floor. So sorry, the first index 0 is up in the air. So we need to skip that one. So that's good. Gives I plus 1. And then here we percent 15 and then plus 1 again. Hold on, that doesn't make sense. Because that means that the first thing is going to be the same. Okay, so there are 15 things on the bottom, plus a 16th point up top. So I guess it's I plus 1 and I plus 2 percent 15. That could be it. That could be it. Okay, let's see what we get now. Let's see what we get now. He's not happy. So 0, 1, 2, 0, 2, 3, 0, 14, 0 feels wrong. I wonder if it's like something like this. So now we have 3, 4, 1315? So it feels like there might be one too many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No, that's kind of right. Sure. Import. OBJ. Why am I not seeing the faces? Can we go the other way? Let's look at the, feels like it should be fine. I'm not really sure why he doesn't like, oh, maybe because they're one indexed. I think they're one indexed. I do think they're one indexed. So everything here needs to be like, 1. Okay, let's see if that does something. Import obj. Okay. Okay, that's close. Except that we fucked up a little bit. So this should be probably like something like this. No, something's wrong here. Something's wrong here. We want like left is equal to I, right is equal to I plus 1, percent 15. We'll start there. Then we literally just add 2 to both of these at the end. Let's try that. Let's try that. First of all, let's look at the file. Cone 1, 2, 3, 1, 3, 4, 1, 4, 5, 116, 2 feels kind of wrong here. Oh, no, that's right. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, okay, that may be right. That might be right. Let's try it again. Import. OBJ. Cone. Hey, that's a cone, baby. You can't tell me that's not a cone. Let's go. All right. Sick. So now let's try to hook up the line parts, right? So remember, we are trying to draw something where every point on our line is represented by a cone, right? So if we were to do 2 cones, actually, we could do that. Let's do 2 cones. So let's do pub function add cone to obj. And we're gonna put like the center of the cone, I guess. Center. And that's just basically, and I guess the writer as well. Okay. And I guess here we're gonna like take all of this stuff, slap it in here. And here we're gonna be like add cone to obj writer, and we're gonna be like 0, 0. And we'll put 1 at 1, 0 as well. Okay. Now for each of these things, we need to basically add the center x and y here. Cone King, hell yeah, dude. So if we do this now, we should see 2 cones. Okay. Add object, import obj. We do not. That's annoying. Why not? Yeah, something's wrong here. Oh, because do we have vertices somewhere out there? We have a problem here. Let's look at the data. Oh, we need to maybe specify multiple objects here. Oh, can we do like writer print oh? Well, let's actually modify the thing manually first, just to see. on cone. So I think we saw that you can have like multiple objects in here if you write like O cone and O cone 2 down here. Right? Can we do that? Cone, cone, cone 2. If I import this, there we go. Okay, hold on. So these guys have the same position, which seems wrong, right? We were supposed to see that Coney had these things offset, which we do see here, but maybe the face indexes still have to be like offset. That's very possible. So can we just be like in here, like f offs is a usize, and here we're just gonna be like plus f offs on both these, right? And then here we'll write 0, and then here we write like 16 or something. I just want to see what happens if we do that. Import cone. Oh, oops. We did want to still be O cone and O cone 2. So now we're still using 1 here, which is a little bad. I guess we should be at cone offset, but let's see what happens if we import that first. Surprising. I don't really understand why like these vertices aren't like hella offset. Maybe they're like centered anyways. Hold on. Import wavefront obj. Maybe I'm just like hella zoomed out now. Oh, wait, hold on. They are offset in X. Wait, I'm just a dumbass. I'm just a dumbass. Hold on. We're close. Let's just offset by like fucking like, 8 or something. It needs to go far. And then here we need to write the name. Maybe we can just do this for now. Okay, hold on. Import, wavefront, cone. F offset +1. Import, wavefront. Let's go! Those are 2 cones, baby. Okay, so this is our 3D representation of this, right? For each point in the world, we want to generate 1 cone to go with it, right? I think that we should refactor this function into like a obj writer, right? And here we're gonna be like, we're gonna have add cone to object here. We're just gonna keep the writer here, which means that this needs to be a function because we don't know what the type of writer is. So he takes in a comp time type writer as a type and returns a type, which says return this struct please. Boom, 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 boom. And the writer here is a writer. And then here we're gonna keep our face, our like face offset is going to be stored here. So now here we can be like take in self as a self. Const self is equal to this, boom, boom, and then we have the center. Boom. All right. So now we can get away with writing self f offs here. Boom, boom, boom. Okay. And that means that we should be kind of close now to being able to add our little line segments between them. So const obj writer is a obj I guess we do our like typical function. Obj writer takes in a writer of any type, returns a type, an obj writer with type of writer. Boom, boom, and then we'd say like return like this. Writer is equal to writer, and f off is equal to 0. And then down here we can be like, just give me an obj writer around this writer. Boom. Okay. And then here we say obj writer like this. And then we don't have to write anything in here except for where we want the cone to live. Hell yeah. He's still chilling. And if we delete everything, how do I A, X, delete. Nice. We import this thing. He's still chilling. They're both in the same spot again, which is not good because here we need to increment our f offset here. 16, I think. I think. That looks right to me. That looks right to me. All right, cool. So we should kind of say const num circle samples is 15, and then we can use num circle samples here, and then num circle samples plus 1 here. Okay, the reason I wanted to do this is because now we can start adding like line segments, right? Because we're representing points as cones, right? And then if we were trying to draw a line between these points, we also need to add like our little tents here. So can we be like add plane to object? And our plane is going to have 4 points. So maybe we do kind of like the same thing where we have some sort of like plane sampler. Oopsies. Plane generator. And what are like our components here? This is specifically for... Okay, so we're going to have like a line at some arbitrary rotation. You can also just use negative index to avoid tracking of the offset. Negative index. Oh, in the object. That's kind of cool. I didn't know that existed. So you're saying that I can go like in like the OBJ. You can use negative offsets here. Nice. That's pretty cool. I'm not going to do that because I already haven't done it, but I think that you're right that that would have been better. Okay. So what are we trying to do? We're trying to say we have like some arbitrary like connection between points, right? Boom. Now we want to generate what are like 2 planes for that thing perpendicular to them. So what does that look like? In X and Y, these 2 points are pretty straightforward. We have them in 2D. We just leave them there. The part that gets ooh. You know what? I just realized that the cone should keep the tip top of the cone should be at 0. The top should be at 0 and the height should go below. So we're gonna do this here and negative height here. Because for these lines, if we want the lines to be on like the 0 plane and everything else to go kind of like farther away, it just kind of makes more sense that way. Okay, I'm struggling to visualize though what like these vectors are. Right? So I guess they are a 90-degree rotation. They're a 90-degree rotation from this vector. So you just swap the x and y and then move in that direction by some distance. So I guess we'll call this like tent generator. And what is like our OpenGL triangulation of this thing gonna look like? It's gonna be like a triangle strip, I guess, from like here, 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 right? So we can go like 1, 2, 3. Sorry. 1, 2, 3. That's one triangle. This goes away, and then we add this one, so that's this triangle. Then this goes away, and we add this one, and that's this triangle. And then this goes away, and we add this one, and that's this triangle. Yeah, so we want like a triangle strip. A triangle strip that starts off to the side and moves this way. Okay. And this is going to return some like vector 3s, I guess. And we are going to generate this thing from our like initial vector. Right? So this is going to be the point, the 2D line that connects 2 points. So our here we have like our if we're pointing to the right and we want to point to the left, is that what we want? No, we're pointing. Sorry. Let's draw. We'll draw. We're pointing up to the right. This is like 1, 1, right? Then we want to point up to the left from a 90-degree rotation. This is going to be now. Let's do at like a little bit of a lower angle. Okay, so this is like small or big, small, and this is going to be negative small, big. Yes. Okay. So perpendicular is the initial vector negative y on the x, right? And positive x on the y, right? That's simple enough. Now we want to walk by some distance along that line. So we're gonna have to say like width of this thing. Okay. And so now we want to go. I think we actually want to store A and B here as our like initial points, because we need to go perpendicular to each of these points, right? So our initial vector is going to be like, we don't have like a sub. We don't need it because these are things our thing. We can just do B minus A, right? Boom. Simple. Perpendicular is the initial vector swapped. And then depending on our index, I guess we're going to be like, we're alternating relative to A and B. So we're going to be like index %2 is going to be like our reference point. Okay. And then the direction that we are walking is going to be self index over 2. This is going to give us 0, 1, or 2, minus 1 to give us negative 1, 0, or 1. And then I think that actually kind of gives us exactly what we want. Const perp direction is equal to this. And we can just be like F32, so we can go like as F32 float from int of the index. Oh yeah, that feels right. Over 2 minus 1. So then we just say we have like A and B. Okay. At ref point index, we'll call it. This is now our ref point. Oh yeah. Then we say ref point plus perp times perp dir. And I think that this needs to be a splatted thing. So we need to go vec2 here and then splat it out. Splat that motherfucker. To basically say, like, duplicate this thing for each axis of this vector. That makes this kind of just work. I'm like not really convinced that this is wrong. That's kind of fun. Oh, we need to multiply by the width somewhere. So probably that goes along the perpendicular axis. Probably. Okay. So we initialize this thing and we make a tent generator. So we are gonna take like points A. I guess there's really not much to do here. It's literally we're just gonna like set the parameters. We don't need an init function. Okay, let's fucking try to generate a tent. So A, let's say that we're trying to go from these two cones. We'll use the same points that we've got here. So let's kind of like move them a little offset on one of the axes here. So we'll say A is 0, 0, right? Chilling. B is going to be the same 8, 2. Maybe we should make these, variables instead of just writing them twice, but you can't make me. And then what's the other thing we need? The width. So can we just be like, width is equal to 4.0 or something? I don't give a shit. Because presumably the width of this thing is supposed to be the same as like the radius of the cone. Presumably, I'm just taking a guess, but I think so. What does splat do? If you have like float x equals 4.0, you have like vec2 x2 is going to be splat of x is equal to 4.0 4.0. And if this is like a vec3, then you would just have like it just duplicates it however many times. Memset for a vector, that's a good explanation. Yeah, I like that. I guess here now we're gonna have to keep track of our index here, and we're gonna have to say like if self index is greater than or equal to 6, there's 6 points. Return null. And so now we can do like while tg next point. Let's just like print the point and see if we think it's reasonable. Point. Hello, streamer. Hello. I actually want stood debug print, not stdlog debug. And then he's pissed about something. Unable to resolve comp time value. Does this have to be like to lin vec2 or something? Why does this not work? Ref points. Do I have to make this like its own thing and then index it with ref points here? Yeah, maybe. And then he's mad about these things being vector 3 as the output. That's true, huh? So we need to construct some sort of depth from this, but let's just start by making it flat. Because I don't really understand what I'm supposed to do. Const, we'll call this ret2 is whatever the fuck we did here. And then we'll just return ret2 0, ret2 1, and then like 0 as our like final element there. Because I don't know what's supposed to do yet. We also have to defer self index plus equals 1. Okay. And we do get, okay, can we start without any angle here? Let's literally just go like 0, 0 to 0, 1 with width 1.0. So we should see something that's like resembles a like square, right? So we go 1, 0, 0. This feels wrong to me. So if we started with 0, 0, 0, 1. These are our points. So we believe that we should start by going perpendicular to this thing, right? So we have our initial vector is 1, 0. Our perpendicular should be -1, 0, 1, right? So our first thing should be here, which I believe is what we got. Our first thing is there. But then our second thing should be here, 1, 1, which is not what we're getting, which is a problem. So why not? We have perp dir. Dude, what am I looking at here? We splat something? That seems wrong. Our perp direction needs to be times perp. Wait, what the fuck? What am I looking at here? So we have, oh yeah, perp dir is either -1, 0, or 1, right? So initially it is 1. Oh, we were expecting integer division here. So it should be like this. There we go. So it's 1, 0, 1, 1, 0, 0, 0, 1, -1. Yeah. That's looking pretty good. That's looking pretty good. So now let's kind of try to figure out how to offset z. So if we're trying to draw a tent, we kind of want like, we want this to have a slope of 1. So we want to go over to the side as much as we're going down, right? So we basically just go width on these things if it's on one of the outside points, right? So we kind of say like abs perp dir, I think. So we'll do const perp dir is the non-splatted version. Okay. Then we will perp dir splat like this, because that allows us to do depth is the perp dir times self width, and then we can put depth here. Oh yeah. Oh yeah. Tell me that's not cool. Tell me that's not elegant. Tell me that's not elegant. So we get 1, 1, 0, 0, 1, 1. Tell me that's not fucking cool, man. Okay, let's try to like render this thing now. So first of all, I guess let's try putting in like our A and B positions here. Okay. Okay. So we'll make a cone at A and then a cone at B, and then we'll make a movement from A to B. That is not fucking cool, man. You asked for it. Fuck. You're right. So yeah, we go from 0, 0 to 8, 2, and then we're like offset by some amount on there. Our width is too skinny, so let's make the width 4.0. We should see like these points get kind of like farther away. So 2 times 4 is 8, -8 times 4 is 32, 1 times 4 is 4. That's looking pretty good. So let's try to like inject this now into the let's try to inject this into our object. So we want to add tent to object, and I guess this is going to take in A and B. Okay. This is going to create a tent generator with those parameters. Width is fixed right now. Let's just kind of put like object width or something as like 4.0 over here, so that everywhere we're at 4.0 now, we can just write opt width, kind of keep that thing constant. Okay, So now what do? We basically write each of these things like this. Our center is kind of encoded in the thing we made, so we can kind of ditch those. And then we need to write out our indices. So we have 6 indices. And we have 6 indices, and how many faces, though? We have, this is 4 faces, right? 1, 2, 3, and 4. So really the f-offs is really more of a v-offs, to be honest. Okay, because we're not offsetting how many faces we've looked at, we're offsetting how many, the vertex index. And then we're going like, each of these things has 3 elements. So this is actually, we're writing 4 faces, and each of them is literally just like, so if we have vertex offset of 0, we want to say 1, and I is 0. So it's like v-offs plus I plus 1. So we can do this. And then here we'll just go like start plus 1, start plus 2. That feels right to me. So can we then try to write a tent that goes between those 2 things? Add tent to object AE. He doesn't like that for some reason. Why? F-offs is mad V-offs, I guess. F-offs. He's mad? Why is he pissed? Oh. Is it because I didn't, like, use self here? I did. Why does he think this doesn't exist? Am I fucking stupid? Oh. I am stupid. Okay. Moment of truth. Let's see if we get a little tenty that goes between these guys. Fuck. Import obj. Close. Our vertex offset is off a little bit. For some fucking reason. We forgot a +1 there. Let's try that again. But even then now, it still feels like kind of wrong. So we do have the corners of our tent do match up with the cone. But something about like whatever the fuck we're seeing here seems kind of fucking wrong, right? Like, I would think that this should look kind of like, I don't know, like more like this. That's kind of what I was expecting to see. So like, I guess it makes sense that the depth here has to be negative, but even then it feels like way too wide. So when we sample the circle, the obj width is going into the height and the radius of this thing. So I would think that the distance from the center of our thing, perpendicular times width, should be fine. Oh, we probably have to normalize our initial vector. I would bet we need to normalize this thing. Okay, let's take a look at that. Let's see if that's any better. Oh, tell me that isn't fucking sick. Come on. Come on. That's so awesome. So we have now represented this point to point movement as a 3D thing. And now if we shade all of these such that the depth is the value, we should be able to actually we should actually be able to look at our distance field here. We just have to figure out how to like make our shaders. So if we go in here, we go like use this thing, and we will use the object depth. Can we do like a texture coordinate? We want like the like world object. I guess object is kind of the same. Is there no like world coordinates? Yeah, okay, it's fine. Z as the color here. And then we probably have to like do some math here where we like scale this down to something like this. And then we probably need to invert it as well. Negative 0.25. Yeah, there we go. That feels right. And we just need to apply this same shader to these as well. Oh, yeah. Like, now, do you guys understand now when you look at this how this is a signed distance field? Or a distance field, right? We have like a really black line at the front, and this thing kind of like radiates out. It would be cool if we could like amplify the like the size, but do you see what I mean now? So we're kind of like leveraging the 3D geometry. The depth is like the value of the distance. That's pretty fucking sick. That is pretty sick. So now I think that we have like successfully generated some 3D geometry. We've successfully visualized this thing in Blender. And now I think that we need to somehow like hook up to OpenGL. But that's pretty sick. I think that we could probably stand to maybe increase the number of samples in our cone, to be honest. But otherwise, looking pretty good. Looking pretty good. Okay, git add source geometry. We'll say whip distance cones and tents generated for distance fields. Okay. Now, what are we going to do here? We are still going to use this tent generator, and we're still going to use the cone generator. And I guess let's just start by trying to render a cone in OpenGL land somehow. So what is like the easiest way to hook that up? Somewhere, maybe in our drawing, when we call our, we have somewhere in here like a stroke render program. And in here, let's just not do whatever the fuck we're doing and try to render a cone. I think that's probably the play. That's probably the play. So I think that what I want to do is I want to make one cone, and I want to instance him at each point there is a point. There's this thing called like instance drawing, where you can import a mesh one time, and by specifying some extra attributes somewhere that I don't really understand, you can like make copies of him all over the place. So I think what I want to do first is I just want to make a cone and just render that fucker in the center, and then we'll figure out how to instance him later. So can we be like, I guess our line program very likely is doing the right thing already, right? What's our line program doing? Our line program uses the path vertex shader, which takes the transform position of a 3D point. Oh, it takes a 2D point. Okay. So right, because our transforms are all 2D right now, which might be a little bit annoying. Okay, so let's kind of start by saying like, we'll call this like a distance field vertex shader. This thing is going to take in 3D positions, okay? And let's for now not give him a transform, and we'll think about that later. And then we'll literally just be like, slap that shit in the output position. Like this. Then we need a fragment shader to go with this thing, right? Distance field fragment shader. And here we're just going to be like, let's copy another one to make sure that we have something that's like semi-sane. And we don't give a shit about anything right now except for the output. And we're literally just going to be like, maybe we use the, can we do like in float depth here? And can we use that as part of our fragment shader output? So we can go like, give me depth over negative 0.21, 0.25 or something like we were doing before in Blender. Okay, nice. Noise. So that should give us something that fades towards white as we get farther away, I believe. Okay. So distance field vertex shader, distance field fragment shader here. We'll call this the 3D DF program. Kind of say fuck everything else that was going on in here. Let's just make sure that we have somewhere to go back to later if we... I think we do. I think we're chilling. So let's just kind of like just start nuking everything in here. Fuck everything that exists in this thing, and let's figure out how to make a cone. So cone vertex buffer is going to be a GL uint, and then we're going to have a cone vertex array. Right? That's kind of all that's going to exist here. So it'd be like cone VB is equal to cone VB, cone VA is equal to cone VA. And we have to figure out how to make these things for sure. So I guess we're gonna be like, we need like the geometry thing that we just made. Okay. And what are we gonna, we're gonna like, I guess we can like predefine how many points on our cone. So this is gonna be like 16 vec 3s, right? Then we're gonna be like, what? We're gonna make some sort of like cone sampler. Okay. Which takes in height is equal to 2.0. We'll figure this out later. Base sampler. Oh, we call init here. Init. With radius, height, and number of circles now was 15. 1 minus cone, the number of cone points minus 1. Okay. Yeah. While cone iterator to next lm point, we just say cone points at I is equal to point. Simple. That's really quite simple, you know? And then we say I plus equals 1. And then we need to upload this thing to the GPU in some way, which surely we have an example of somewhere. Here, GL bind buffer, so we'll just kind of copy all of this shit and figure it out later. So here we're like, we have some cone VB, okay, which we generate with gen buffers, okay, which we might delete if something else goes wrong. That makes sense. Then we bind this buffer, okay, and we say, let's fucking slap some things in here. So I guess we look at the cone points here, and the cone points as a pointer here, and that stuff ends up as statically drawn. We don't change that shit. Okay. Then we create a vertex array, and this defines how the data is laid out in that thing. So I guess we have one input attribute, which is vpos location, which we have to like extract somehow. So we say, get me that attribute location from our program, please. Oopsies, where the fuck was I? Okay, so we say, get me that motherfucking position, which he's saying is actually redefined. So we've actually already done that, which is pretty damn sick, except we're in the wrong spot, which would make sense as to why we are doing that. So here, give me that vpos location, and we need to come from the df program here, distance field program. And what are the attributes here? We have the index, okay, cool. The size of this thing, 2. So here I guess is going to be 3 floats now, non-normalized. And what's the stride here? The stride is going to be 3 times 4. We have just the vertices. That's it. Sure. And this is no longer vertex array. This is a cone VA. Boom, 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 boom. Okay. So theoretically, we have a cone we can render now. So now when we generate the distance field, can we just, instead of doing whatever the fuck we were doing before with this flip-flop shit, can we just use the df program here? We don't have any uniforms defined. And then can we like just fuck doing whatever the fuck we were doing up here and just like draw arrays with like the cone size? Cone points is going to be 16 here. Oopsies, num cone points, I guess. And then here we can go num cone points here, and then down here we should be able to render num cone points things. Okay, and we want to render these things as like a GL triangle strip. Triangle fan, sorry, triangle fan. And this has, we go from 0 to that many points. That seems reasonable so far. I don't really see any reason why that wouldn't work. I'm sure that we will find out that there is a good reason for it later, but I don't know what it is yet, so we can just ignore the problem. Fuck! 579, renderer var I usize equals 0. Return is missing subprogram. Fine, we will still use that, I guess, probably. Object.zig, align vpos location. Fuck. Okay, let's just ignore that right now and say line vpos location will still exist. We'll just make it 0, and it might have to be a GL int. Yeah, GL int, not GL uint. Does anyone know how to get the 4 corners of the quad per pixel in this texture space? I throw width and height in as uniforms, and then divide UV by, like, multiply UV by width. I don't know if that's, like, the best way, but that's how I do it. 616, he's pissed off about, you know, some stuff. We need to discard the allocator. And itself, we'll come back to this later. I don't really give a fuck right now. I just want to build. Okay. And now if we go into create drawing, we're kind of seeing oh. I don't really know what the fuck I'm looking at, to be honest. It feels like it's doing something. I just can't really pinpoint what. So what happens if we make like the cone radius smaller? So can we call this like depth radius? And can we make it like 0.5 or something? I want to be able to see, you know. I just want to be able to see it. So if we do a triangle fan, we should be starting at 0.0 and moving our way around. And then can we also just make this thing like for now 1.0, 1.0, 1.0, 1.0. We'll just draw the whole fucking thing as white. Just until we have like a feel for if it's like at all correct. So that feels bad to me. Right, the fact that the whole screen is turning white is bad, but also I believe our clear in here, our clear color is red. Okay. So if we just don't call this, we don't call draw rays, we should see it turn red. That's kind of the state we expect right now. Create drawing, click something. White though. Why white? because the texture that we drew should be red. We make a texture of this size with RGBA input. We literally just do nothing but say, hey, bind this texture as our frame buffer. I want you to like viewport the fuck out of this thing. Clear it with red. And then do nothing. Then do we like, we only do clear this thing on error, okay. So why is it showing white there? That's not good. Yeah, that's not good at all. Not good at all. Unless bind frame buffer 0, delete the frame buffer. This is strange to me. Because this isn't very different from whatever we were doing before. This thing is supposed to return a texture. Fucking OpenGL, man. Is it because... So our program literally shouldn't be running right now. I guess the sub-program could be a problem in some way. Yeah, what is this doing? He's saying, give me the plane thing and the brush fragment shader. Oh, he is rendering the distance. That's fair. So maybe this is right. So if we go back here and we say clear black, I think that this should show black if everything's working correctly. I think I was just confused about what was happening here. Because the texture turns red, but then we only look at the red channel of the texture and then like duplicate it. So here we go black. Okay. That's chilling. Okay, so now let's try to draw our triangle fan again and see if that does anything. I don't know if it will, but I would be, you know, a little happy if it was. Okay, create drawing, click somewhere, click. Okay, so this is back. So anything that's white right now is stuff that it tried to draw, which is kind of confusing. So can we just draw one triangle? Instead of doing this, can we do like GL triangle and go from 0 to 3? Let's literally just draw the first 3 points in our cone, and hopefully we should see something that seems sane to us. Okay. It doesn't really, huh? That doesn't seem sane in any way, shape, or form. So why? Can we look at the cone buffer that we're using? Cone points is this. What language is this? We're using a combination of Zig and GLSL. So the first 3 points are at 0, 0, 0. Oh, wait, okay, 0, 0, 0. Then 5, 0, negative 5, 0.5. Oh, 0.5, 0, 0.5-ish. And then the third point is something else. Can we like reduce the number of samples in our cone like heavy? Can we like say like, let's really give us like 5 points for our whole cone? Because that should give us kind of like a diamond, I believe, which should be easier to reason about in this picture. Okay, wait, that kind of makes sense. So this is the first triangle, and he's going 0, 1, 0, 1, 2. Which makes sense, right? 0. It is still too far, though. It does feel like it's going the full distance instead of 0.5, which is a little concerning. I would think that there should be like a black border around everything. But let's increase the number of points that we draw now. So can we do a GL? First, let's do a GL triangle fan. Let's see if that still looks the same. Okay. If not, we might not understand the triangle fan. So that looks the same. And if we up this to now, say, give me 4 points for the fan. I don't know what this will do. Create drawing, drawing, click. See, this is where the shit gets weird. Because I would think that he goes these 3 points, then these 3 points. Which seems to me like it should be going center of the screen, up, left. Which is not what's happening. Which is not what's happening. We're seeing some like weird shit happen instead. I wonder if we just didn't bind our vertex array. You know what? I don't need to hear your shit. Okay? Sometimes you don't use the data you were trying to use, okay? And you know what? Sue me. Okay, so now we're just seeing like jack shit. Which is kind of more confusing, I'm not gonna lie. Like a lot more confusing. So now it's just drawing nothing? Why? Yeah, pretty confusing. I wonder. Hum, hum. Okay, let's go back to trying to draw a triangle strip from 0 to 3. GL triangle strip. Did I spell it wrong? I don't know. Okay, there's a bunch of things that we could have done wrong here, so we're gonna have to slowly bisect. So these are the first 3 points in our buffer, and the fact that we are not seeing that when we try to draw a triangle strip is very concerning to me. Right? Because this should be like pretty straightforward. Which makes me think that we've done something wrong here. I would like to try saying, just in case something downstream is fucking us over, let's say bind vertex array 0 here, and GL bind buffer GL array buffer 0. Let's just like make sure that nobody else can like accidentally fuck us over. I don't think that's it, but you never know. You never know. Okay, yes, that's not it. Well, maybe that's one of the problems, but as far as I can tell, that's not the problem we're seeing right now. Let's look a little closer at this thing. So we're supposed to see in vec3 vpos. And we are saying, give me the vpos location from our df program, chill, okay. Then enable the vertex attribute array at vpos, chill, and could you please create this thing that is 3 floats, non-normalized, stride of 12. Is stride wrong? That's possible. What is like... I guess here we need like size of vec3. There's a possibility of something going wrong there. Okay, so let's try that. What the fuck? Create drawing, drawing, click. So nothing there either. Why? That's confusing too. I guess we could start. Is it a problem here with GL? But cone points len times 4 is the size in bytes. This is wrong. This should be times size of lin vec3. So there's a possibility of a bug there. Create drawing, click. There we go. That's what I want to see, baby. Okay, so now let's try to up the number again. So let's try to draw a triangle fan. With num cone points. So now I'm hoping to see a diamond. Hoping to see a diamond. Okay. Okay. We're close. Maybe +1? No? So I think that there's a bug here. Num cone points is 5. So there should be 4 points around the circle at the bottom. Which means that here we should be passing 4 into this, which gives us 4 circle samples. And I think that we probably have to handle the wraparound ourselves. That's what's happening here. Is like, why is my computer fucking falling over? Am I like fucking dying? Like, what's happening? It's fine. I think what's happening here is we have like, we generate in our cone like the top point and then like 0, 1, 2, 3. And then the triangle fan that's drawn is this triangle, this triangle, this triangle. And we have to fill in this one by ourselves. Which is a little annoying. It's a little annoying. What we can do is we can just kind of put that point back in ourselves. Doesn't seem crazy. Does not seem crazy at all to me. So maybe we do something like this, and we just kind of say cone points I is equal to cone points 1 is, yeah, cone points I is equal to cone points 1. And we'll just say manually inject wraparound case. Okay. Seems maybe reasonable. Okay, so we got our diamond now, and then like let's crank up the number of points to like 12. And then hopefully we should see kind of like a circular thing that's maybe jagged around the edges. Maybe? Yeah, okay, so we got like a little stop sign there. Let's go a little farther. Maybe we do 20 even. Let's get crazy out here. Alright. I'm concerned that my computer is slowing down, and I don't know why. Seems like everything is fine. I don't know. Memory available. We only have 2 gigs of free RAM. Why is that? Who's using all my... Used 11 gigs. We do have some stuff sitting in DevGem, but like a little bit of Steam leaking shit again, but nothing crazy. Yeah, it's a little concerning. And if I like do this again, I don't know, let's just not think about it. I guess we could maybe try getting rid of some Firefox. Like, let's just kind of kill this for a second. I don't want to kill everything in Firefox, but we do have to fucking get some out of the way. What is like this? Okay, kind of no consequence. I don't know which thing that was, but it seems fine, so we'll just not think about it. Something in Firefox was just like killing my RAM, but whatever. Whatever, we'll come back. It doesn't look like anything's dead. It looks like... Okay, we won't think about it. Okay. So we can now draw a circle. Now the problem is the aspect ratio of the window needs to be accounted for here. So how do we fix that? We're probably gonna have to scale the cone in some way by the aspect ratio, right? Right? So how do we do that? We kind of want to make it, well, actually, before we do that, let's try to make it so that we can like look at the depth here as well. So can we use depth, like 1.0 minus depth or something? No, we want distance to be 0 towards the center. So we want like negative depth here. Yeah. Okay. That's not good. I was kind of hoping to see something a little bit more interesting there. Our depth does range from 0 to negative 0.5. So we should have been seeing something here. I guess we don't ever set the outfloat here, though. So we kind of want this, like this, maybe? So we specify the z value, we pass that on to the fragment shader, and the fragment shader is allowed to interpolate that however they please. Let's see if that's a little better. There we go. That's not bad at all. That's not bad at all. Okay, so there is our point. I would like to make it circular. So how do we fix that? It's something to do with aspect ratio. I know that much. And we can define... We want to make it so that our cone can maybe have like one normalized parameter. 1.0. And we want to say 1.0 can be like the maximum distance that is seen in our image. But the problem is we need to keep the points correct in object space. We're going to place this thing at individual points in object space. So maybe we do the squishing on CPU side or something. Well, the aspect is like part of the render function. So I think that we almost want to track the like width and height of the cone separately from the center. Right. Okay. So let's just make a like simple cone. A simple cone, he's going to have radius 1.0. We'll start there. 1.0 radius, maybe even 2.0 radius, but we'll start with 1.0. And we have to make some sort of input now that we can use to adjust the like fatness of the cone without changing its position. Right? That's going to be the next thing. So say we want to instantiate the cone. We're going to want to move the cone in some way, right? So we're going to be like uniform offset. Yes. Yes. So there's going to be a vec2 offs. And then we're going to have like a vec2 scale. Right? So we'll scale it in X and Y, then move it. I think that makes sense. So we can do like a... Do we want to scale it in depth as well? I think not. I think we always just want the farthest thing to be 1.0. I think that's probably pretty reasonable. I'll have to think about that a little bit, but we can start here and see how it works. So we'll be like v pos xy times scale plus offs. Okay. GL position is equal to vec4 of this thing. With v pause z and 1.0, kind of just hard coding in there. Okay. Seems reasonable to me. And then we'll say, let's say like 0.3, 0.3 or something. And the scale, actually, we'll set these we'll set these where they need to be set. Okay, so let's start over here and we'll be like, somewhere we need to like find the uniforms in this thing. Get uniform location. So we have that here. So boom. Offset uniform lock is the offs, and the scale uniform lock is going to be scale. These come from df program, and then we need to store those. So df offs lock is whatever the fuck this thing is. So this thing returns a gl int. And the scale location is the same. We will name these the same thing, I guess. Okay. And then here we'll say, we'll write those things down. gl int and scale. Oopsies. What am I talking about? This is df offs lock and df scale lock. Now we have to set those uniforms before we render. So the scale gl uniform, we want like 2 floats at self df offset location. So let's try to put it like 0.3, 0.3 or something, right? Then the df scale location, we want to expand one axis, the smaller of the 2 axes, right? So we have like aspect is going to be something like chords calc aspect of width and height, chillin'. And I guess if aspect is greater than 1.0, we're going to do one thing, otherwise we're going to do another. So if it's greater than 1, that means it's really wide, right? Which means that we kind of need to stretch the world. If it's like really fat, that means that our thing is going to look like this, right? Which means that we need to stretch it vertically such that it looks circular still, right? So can we do something like that? So we do like 1.0 for the x scale, and then the y scale is, if it's big, then we want to make y bigger. So we say aspect. Then in the other case, we want to keep height the same, and it's going to look like this. Ooh. Which means that we want to stretch it horizontally, but aspect is small. So we want to do 1.0 over aspect and width. Okay. We can kind of see if that works out. So now we create a drawing, we click, we draw, and that looks pretty damn circular, which is pretty sick. Now its distance needs to be adjusted a little bit. We want to make it so that in a square image, we want to make it so that it kind of looks like this, right? Everything in the image is contained within the circle. Now, we also have to make it so that if the point was drawn here, that is also true. So I think that we want to make it like, this is root 2, right? Is the and so I think that we just want to do like 2 times root 2 as the radius. Kind of my bet here. 2 times stood math squirt 2. That's just like a real shot in the dark, but it kind of feels, fuck. So here, why the fuck did that not work? Why did that have no effect? That's kind of weird, right? Right? That should have done something, right? If I were like 100 here, surely that should do something. Surely. But it doesn't. So why the fuck not? Why the fuck not? Because when we generate this cone, key is used for radius and height. Radius gets used nowhere, and same with height. Also, height gets used, but the radius doesn't. I see. So we just need to do one of these things. Oh wait, hold on. Maybe it does. It's supposed to get used here. So it is. Point times radius. Okay, can we like look at the print? We print the cone points here. So if we have like here, we see that we have like 0, 2, or like 0, 3-ish, right? Now if I put like 100 here, we get like 0, 100, right? So that seems pretty reasonable. If that is true, I do not understand how this thing... Oh, we're getting clamped by the depth, maybe? Yeah, we're getting clamped by the depth. We're going out of the bounding box. So we actually need to scale the depth? That's interesting. So the height of this thing actually can never go above 1.0. I bet you that's the problem. I bet you that's the problem. Because otherwise it'll go outside of like the OpenGL bounding box. There we go. That's looking pretty sick. Looking pretty good if I do say so myself. Okay. Cool. So now we have points handled. Can we draw some lines now, maybe? That'd be kind of cool. So I guess what we want to do now is we want to draw that point everywhere along the line. We haven't done that yet, so that's probably the next thing. Right, so we kind of want to go... Right now we're kind of specifying this thing by uniform. We have to figure out how to do instanced drawing, which I haven't figured out yet. So draw, OpenGL, draw instanced. I think that here they talk about how you are supposed to specify your parameters for this thing as a thing in your vertex attributes. And then somehow you say, I want to make it so that this attribute is incremented for every instance of the thing I draw or something like that. So how do they do that? What's the text editor you use? That's Vim. Vim. NeoVim if we're going to be exact, but I don't think it really matters. So I think that they have two separate array buffers here. I think that they set the data for the thing in like one array buffer, and then they set the instancing data in another one. That's kind of what my gut says. Instance VBO. So what do they put in here? Yeah, so they just have like literally like translations sitting in here. I didn't know you could do that. That's kind of interesting. So you like set the point data as like one vertex buffer. And then down here, when we're like rendering this thing, we kind of like walk our this thing that this is getting a vertex arrays. That's kind of not what I want anymore. I want this thing to take in a list of points. I think. So our strokes, we have many strokes. Each is a segment of lines. So can we start by just doing only one line? We will only support one line. I think that's reasonable. As like a starting point. So here, this thing will take in like a point iterator, I guess. And then we can go like while point iterator next. We basically want to like push some stuff into a vertex buffer. So we want like a std array list of vec2 initialized with an allocator, which we may or may not have at this point. It looks like we do not, but we can pass one in, I guess. Okay. We will say that these are our cone offsets, right? Seems reasonable. Seems reasonable. We'll be like, later, we're going to ditch these things. Okay, fuck that shit. But we then will say, for each point, we're going to be like, yo, give me one of these things. And we'll assume that it's just taking in, like, vec2s for now. Okay? Now that we have them all, we can be like, okay, so can we put these things as offsets? Which, how do they do that in here? They bind an instance VBO, so they make their instance VBO. Fuck. So we'll kind of do it this way. Boom. So this says offsets VBO. Offsets VBO. We unconditionally will free this thing later with offsets VBO. And then we put this stuff in here. They use array buffer? They do. So then we just upload the data, which is going to be in cone offsets .len times size of vec2 now. This is vec2, not vec3. And this is items len here. Then we look at cone offsets items pointer. Okay. So now we should have this stuff available to us. And then they say, let's clean our shit up. That's pretty reasonable. Clean our shit up. Then they're like, okay, I would like to bind. Let's like set up our like attribute array. So it's gonna be kind of like okay, first of all, before we do this, any of this, I just kind of want to see what happens if we do this really quick. Fuck. Hold on. Alec, sorry, we can come back to this. I think this should build. Fuck. 638 in renderer. Hold on. I want to make sure that I don't have to bind the vertex array for the vertex buffer for the cone every time. I think that should just kind of stay the way it is. Nice. Okay. So we're chilling there. So fuck this bind buffer. And then we bind our vertex array. We set up the cone offsets. That's cool. And then we're like, enable vertex attrib array at the position of the cone offset lock, which is something that we now have to store. So in the same way that we like get the vertex position, can we look for the offset? So instead of this being a uniform now, we're going to take in offset as an input, right? So that's kind of like this. And I guess we should call it voffs for consistency. Cone offs lock. And then that has to get stored here. So this goes away, and this turns into something like this, I think. Yeah. Okay. Okay. Then we do whatever the fuck they were saying to do. So we enable this thing, we bind our buffer. So we can just do this later. Okay, so our shit is bound. Hell yeah. Maybe we do this way. It's fine. Then we set the attribute data here, right? So we say, okay, we have no offset. We are every 2 floats. So I think this is still fine. We kind of can copy this, except we have to specify things a little differently. So this is the index is going to be int cast of self cone offs location. Okay. Then the second thing is the size. So 2 floats of type float. Okay. Not normalized. 2 times size of float. So the stride is every 8 bytes. And then we use null here instead of 0. Okay. Now, this is the trick here, is that they say increment this thing every time we do a new instance. That's kind of what it's saying here. I don't really know if I understand, but he says increment this thing by 1, I think it says. Every time we do it, by setting it to 2, we would update every 2 instances. Oh, I see. So every 1 instance, advance by 1. Okay. So now we should be able to be like, instead of being like GL draw arrays, we should be able to write instance here. And the mode is still fan. We still draw the same number of points. It's just now how many instances of these things we're going to draw. And it's, I guess, cone offsets len items. However many offsets we had. Which seems pretty fucking reasonable. And now we just have to fix the fact that in our object, we need to generate points instead of a stroke vertex array. So this thing is just like, he's going to output some vec2s. So like for now, can we just be like, this thing returns a vec2, and it's literally just like, if strokes 0 item points items land. Yeah, if self index is greater than or equal to that, return null, else return self strokes 0 points items at self index. Okay, just for now. Just for now. So I think that this should compile. Fuck, it never compiles. So, right, this isn't used anymore because we don't use that offset uniform. Offset lock is mad at somewhere because this thing doesn't exist anymore. True. Out of memory at 671 because this thing can fail now. And he's like, yo, you need to say that this thing can fail because allocations will not always happen, which means that this guy has to write try. He's fine to do that. We keep going. Renderer Zig 679 is mad about an int cast here, probably would be my bet. He wants this thing to be the right size, and then another one over here. Fine. Fine. All right. Moment of truth. What would be very cool is if this fuck, it never works. Okay, offset undeclared in here somewhere, because here it should be v offs. Okay. How's that looking? Huge for us. Okay, and now moment of truth. Let's try drawing something. Nothing. Nada. But not. It looks like it's actually hung, which is not good. Probably because our point iterator here, we probably just forgot to increment it. Yeah. So we're probably just infinite looping here. Classic. I like when I make the same mistake so often that I know exactly where it is without having to think about it. Okay, so here it looks like we only got 1 point here. It's not offset. So there's a couple options here. One is that the offsets are not applying, and 2 is that there's only one thing. So can we look in our offsets here and try to print out what we got? Offsets is this. Simple. Cone offsets items len. Okay. Let's try that. So what we're hoping to see here is that when I create the drawing and I start drawing it, okay, so we are seeing a lot of these things, but we are not seeing them have any effect on the cone that is being drawn, which means that we must be doing something stupid. It's the only explanation, right? So I wonder if we can like somehow tell. I guess the fact that the cone is drawing at all is very likely to be good. It's probably, did we log the offsets? Let's log the offsets themselves. Let's see if they're in reasonable positions. That's going to be the next thing to look at. create drawing, drawing, boom. Okay, so we are seeing a bunch of varying offsets. There are a lot of them, but we do see that like within one thing, we are ranging from like, 0.1, 0.1, 0.5, or 0.05-ish. They are like kind of moving around. Let's try to make like a line from the bottom right to the top left, or bottom left to top right, I guess. So just to see, so here we're like close to 1, 1, and here we're close to -1, -1. So we would really expect to see some sort of like dark gradient along here, which we're not seeing. Because we would expect to see many cones being drawn, and that's not happening. So the question is, why the fuck not? My guess would be that this v offs thing is not doing what we expect, right? That's kind of the obvious mistake, because it's like this thing that we've never done before. So draw arrays instanced. Can we look for their example of how they do this thing? So here they say, I'm drawing this quad, which has 6 vertices, and they're drawing that quad 100 times, right? So that's kind of what we're seeing here. And they're trying to draw it with like varying offsets. They say, yo, give me this offset in here as a vec2, which we are doing. I have no idea, but it did have one more bind call. Okay, that's worth investigating, but let me just make sure that I'm happy with everything else first. So they're saying, give me 100 things, and here are my offsets. So I generate a new vertex buffer, which I believe we do, right? We say offsets VBO, and we then bind that buffer here as an array buffer. Then they set the data. So that's what we should be doing here. This could be a mistake, for sure, right? But it should be that we are... I mean, it looks pretty damn the same, right? So we're taking the cone offsets, we're looking at how many there are, we're multiplying by the length of the thing in there to get the offset in bytes, or the size of the thing in bytes, and then we're feeding it some data, and here's the pointer to that thing. So I think that should be chilling. And then they do unbind the buffer here, but that's okay because later they just bind it again, right? So we can ignore this. I'm like fairly certain. Here they say enable this vertex attribute array, which I think that we might not have done, which is very important. Yeah, I think we just didn't do that. So if he's like, this thing is literally not on, that would make sense that it's not being used. If it's not on, it's not on, you know? Okay. So that was interesting. That was interesting because we saw the movement as we drew. But what we are not seeing is we're not seeing like the full path, which is kind of confusing. Yeah, that's pretty confusing. Because we should be drawing this cone like a billion times. I wonder if the depth test is wrong. Oh, we have no depth buffer. We have no depth buffer in our frame buffer, which surely is causing some problems. Surely. So, yeah, I bet you that's the problem. How do we fix that? We need to make a texture for depth. So this is going to be the depth texture. Okay. Then how do we do like frame buffer depth texture? We do, because somewhere they basically need to write down the depth at each point for us to be able to do a comparison, and then he's just like, can't do that. So here, that's his color texture. Where's his depth texture here? Boom, 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 boom. And we want to probably use width and height here. Is make texture common? This binds it, right? Yeah, we're fucking bound as shit. Okay, and then presumably we want to like attach this thing as a depth attachment to this thing. Fix me violating API abstractions. But shut the fuck up. We'll deal with that later. And so this should be, he attaches them with these parameters. So he goes this, 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 and the texture is depth texture. Okay. Let's see if that has any effect. I guess we should also probably clear this thing. We should probably defer depth texture dinit, or else we will kind of allocate a bunch of shit that we don't want. Create drawing. Okay. Still surprisingly not working. I wonder if we have to also enable GL depth testing. How do we like GL enable depth testing? I think we're probably just not doing that somewhere. GL enable GL depth test. Fucking OpenGL, man. Fucking OpenGL. Okay, so now it's just fully black, probably because the depth. Oh, we probably have to clear the depth. That's a good point. So here we want everything to be far as fuck, right? So GL clear buffer FV. How does this work again? If it is depth. Okay. So if this is color, if it's depth, draw buffer must be 0. Okay. So draw buffer is 0, and then we should clamping version for this point depth buffers are performed in the same fashion as GL clear depth. Points a single value to clear the depth buffer too. Okay. So we want the depth to be probably floating point max, right? Probably. Max depth is going to be std math inf f32. Okay. So now we should hopefully see that like it doesn't blow the fuck up. Like we should see something, you know, anything at all. Still just fully black, which isn't good. So it could also be that the depth testing function is not the right one. Sometimes you need to specify if you want less or greater, etc., etc. Depth test function. Can we just look up GL depth func? So this thing says the default. What is the default? GL less. Passes if the incoming depth value is less than the stored depth value. So if we clear with infinity and we have the default of less, then it should work. Hand wavy, right? Right? So why the fuck not? Why the fuck not? It could be also that like the regular, we might have to disable. We might have to disable this thing later because it could be that like downstream rendering code doesn't take this into account. So we should only turn it on while we render to our frame buffer. Maybe that's like a very real possibility. Okay, that's looking good. That's looking good. So we are seeing like kind of like over time effects happen. And now we just want to make sure that the minimum value of anything that we set should be 0. Which I think it is. I'm pretty sure that when we render our cones here, we use a max depth of 1.0, which we set to negative here. We should set this to positive, I think, because we want things to go like into the screen. That's not good. Oh, but then our fragment shader is inverting it again. So here we just set this back to positive, positive, positive. And then I think that should work. That feels like it should be good, but we'll see. Create drawing, drawing, click once. Okay. And then let's try to click drag here. Oh, tell me that isn't fucking awesome. Tell me that's not fucking sick, man. That's so cool. Okay, so what we have here is we actually never implemented the tent part of this, but I think that the sample rate of the mouse is fast enough that cones are good enough. That's pretty funny. That's pretty funny. Yeah, which means that like probably we could continue making this work. For if we made our like point generator that we pass into this thing that gives us the points of all the cones that we want to draw. If we just say like give us all of the points from all of our fucking strokes, right? So it can be like inner index and outer index. And we can say like if self inner index is greater, if self index is greater than self strokes len. We're fucking done. We've iterated every single stroke. But now if we're within a stroke, we should be like if self inner index is greater than or equal to self strokes at the outer index, points items len. Now, if we're in this case, we have to increment the outer index, set the inner index to 0. Okay, and then continue and try again, which kind of means that all of this has to happen in a while true. Nice. Okay, okay. Otherwise, we're fucking chilling and we defer self inner index plus equals 1. And then we should be able to be like, just return this point. Self strokes at self idx points items at self inner index. And I think this is just like the thing return. So this should give us every single point in all after all strokes. Oh, okay. You can kind of see it if you move the mouse too fast. You can see some gaps in here. So this is the sample rate. But we can just kind of ignore that for now. That's pretty fucking sick. That's pretty sick. Okay. So now I guess we just like can we just like do how do we like render this thing? Like after we get the distance field, we're supposed to run some sort of shader on it. Which we're not doing anymore. Unless this thing he uses the brush fragment shader. Okay, so can we use like, let's just put like 1.0 in this thing? Like if we just try to draw red now, what happens? Fuck. Oh, because this needs to be alpha. Okay, so if we do this, does it draw red now? Oh, it does. Wait, that's so sick. Okay, so now let's try to make like a we sample this thing at like a little bit of a closer radius. Closer radius. Okay, so you can definitely see the fact that there's some sampling going on, but that's pretty awesome. Yeah, that's pretty sick. Pretty sick. Okay. Yeah, I'll fucking take it. I'll take it. So, this is kind of absolutely no movement from where we started today. We kind of like we already could generate a distance field before, but the distance field that we were generating was like not circular, right? So kind of like a stroke like this would end with kind of like a diamond point on the side. And more importantly, we were generating it in this like really stupid way where we were flipping back and forth between textures and dilating after drawing. Now we have like a one-shot way to generate an SDF, which is very cool. And it's like really like I like the concept. The abuse of the 3D pipeline using the depth as the way to sort distances. Like if you have like this line and this line, like you end up with like a little hotspot in here, and that's like totally reasonable because like it's drawing cones underneath, and the cones like intersect each other, and it just like picks the one that's closer to the camera. That's like fucking awesome. It's awesome. It's so cool. Yeah, and we generated this like fun little Blender visualization along the way, which is pretty cool as well. So yeah, I think that's exciting stuff. Exciting stuff. I think we can do better. I'll have to implement the tents later. But it's 4:20 now. Blaze it. Bless up. Shut the fuck up. And it means I think that we've kind of put enough work in for today. But this is very cool. Very, very cool. Thank you for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4:30 almost now, so anywhere between 3 or 4 hours ago and now is when you should expect to see us live. We are working on this image editor right now. If you want to see kind of like the history of this thing, this is on YouTube. If you are new here as a Twitch viewer, there is a playlist for this thing. Image manipulation. There's also a bunch of other cool stuff on here if you want to check it out. So there's like QR code decoder, operating system, like some neural network stuff, like I don't know, a kernel module to do regex filtering, like XML parser. There's like stuff in here if you want to check it out. GitHub link in the Twitch description. This project is the SFIMP repo, and this code will end up there, probably under the work in progress branch, probably relatively soon. We'll be back tomorrow, probably. I don't know what we're gonna do tomorrow. We might work on like brush UI or something, or I might decide that it is a happy hour only day tomorrow. I'm not sure. We'll see. We'll see. But I will be online. Otherwise, thanks for watching. YouTube, catch you later. And Twitch, let's find someone to raid.